Welcome to lesson 4.1, Exponential Growth and Decay. This lesson, we are going to be learning two things. One, you're going to be able to make a exponential growth or decay formula, all right? And then you're going to be able to plug into it to make predictions about the future, all right? So you're going to be able to write out a formula and make predictions about the future. Let's look at three different problems, and this is the three different ways you might see a question that would appear on the Regents. The first one is this. Ms. Larici has $2,000 in savings account that has an annual interest rate of 14%. Now I want you to underline with me because these are key facts. We call this an annual interest rate of 14%. That's going to come in handy. Now we want to write a function to represent the amount of money in her savings account and find the amount of money in the account after 12 years. All right, so we got to do two things here. I want to be clear about this. She has $2,000 in her savings account and an annual interest rate of 14%. So that's how much her money grows every year. We're going to write a function to represent the amount of money in her savings account, and then we're going to find out how much she has in 12 years. So we're writing an equation, and then we're making a prediction. The way to do it is as follows. You use this formula. A equals A0, 1 plus R to the T. Now what the hell does that even mean? I'll tell you. There's three things you got to define. A0, now A0 always represents the starting amount that you have. Now this could be money, this could be a population, this could be anything, but this is the starting value, so that's what you plug in here. R is the rate of growth or decay. If something's growing, like the money, then this is going to be a positive number. All right? If it's decaying, then it's going to be negative. All right? And then finally, T is the time. That's how much time you're looking for. All right, so let's take a look about how to write this equation. So let's look at her situation. What is Ms. Larici's starting value? You should write this here. I'll fill it in a second. Well, her starting value is $2,000. She starts off with $2,000, right? That's how much she originally puts in her bank account. Now, what is her rate of growth? 14%. And whatever that percentage is what you're going to write it as. 14 over 100. We always put it over 100. And that gives us, put that in the calculator, 0.14. You always put that in the calculator. Okay? I want to be clear here. We took this number, we put it over 100, and you got 0.14. And T, well, that's going to be 12 years. All right? That's how long we're looking for this. Now that we have our variables, we're going to plug this into our formula. All right? And you need to memorize this formula for the Regents. It is important to memorize it. Okay? So let's write out this formula. So it's going to be A is equal to 2,000, all right, 1 plus, okay, our R is 0.14 to the T. All right, I'm not plugging in T yet. Just keep that there. All right, I'm not plugging in my T. I know it's 12. I'm not plugging in yet. That's just our first formula. This is the first thing you write. You plug in your A, you plug in your R. All right, now we're going to simplify this a bit. We can rewrite this as A equals 2,000. 1 plus 0.14 is 1.14 to the T. All right? So what I did was just simplified. And I want to be clear about something. On the Regents, it might come in this form. It might even appear in this form. All right? It could go in either way, but we're just simplifying now. Now, that is the formula. This answers the first question, though. We're going to write a function to represent the amount of money that she has in our bank account. This function represented, okay, that can tell us how much money she has for any given time period. Now let's actually figure out how much she's going to have after 12 years. So we're going to plug in 12 for time. So it's A equals 2,000, okay, 1.14 to the 12th. And now to figure out how much money she has after 12 years, we're going to go to your graphing calculator, and you're just going to plug this in. So let's do it. 2,000, right? 1.14, all right? Caret, don't forget that, to the 12th. Because we're going to the 12th power, you need to put that caret there. Don't forget. Press enter, and that is our answer, okay? It is A, oh, where'd it go? Where'd it go? 96358. And I'll leave it there. 9635.8. You know what? We'll round it there. Now, I think you should write the whole number to be safe, but I can't keep looking back and forth, so I'm just going to leave it. Now I'll write out the whole number. What the hell? 0.964. Boom. So this is how much money Miss Larici will have in her account after 12 years if it grows at a 14% interest rate. Let's try one more example of this, okay? Number 2. Mr. Siegel bought a motorcycle for $6,000, which is actually true. I did last year. It's so sweet. I love it. It decreases in value 12% each year after it was purchased. So as you know, when you buy something, right, after it's used, the value of it goes down, like a car or a motorcycle. So the value of my motorcycle is going down every year. If he bought the motorcycle in 2009, what will it be worth in 2011? Okay, so we're going to answer that question. What is that doing there? That needs to go. So let's give it a shot. Oh, and if that was on your paper, just cross it out. So once again, this is exponential growth and decay, so we're going to use our exponential growth and decay formula. And we need to define these 3 things first. You always write this out. Now, I wrote this out for you here. When it's not there, you got to write this out yourself. A0RT. All right, if it's not there, you write that yourself every single time. You write the formula, then you write these 3 things. So A0, that's our starting value, right? That's A0, starting value. That's 6,000. That's how much my motorcycle starts at its cost. Now, my rate is 12%. Okay, so that is 12 over 100. You always put over 100, and that gives us 0.12. And what will it be worth? And now the question's asking us, we got to figure out time. So if he bought it in 2009, what will it be worth in 2011? Well, how many years is that? You got to think a little here. If you bought in 2009, what's it worth in 2011? That's 2 years. All right, now to figure this out, we just plug into our formula. So just like before, A is equal to starting value, which is 6,000, 1 minus, all right, because remember, this is decreasing, 0.12, all right, it's decreasing to the t. I'm not plugging in my time yet. Let's simplify this. This is A equals 6,000, 0.88, what the hell? Man, what just happened? 6,000, 0.88 to the t. All right, that's my formula. I figured out my formula. Now let's plug in to find out my actual value. So this is how I figure out the value. Now I have to plug in time now. So A is equal to 6,000, 0.88 to the second. At this point, you take out your calculator. So let's take out our calculator, and we'll do 6,000 times 0.88 to the second. All right, we enter that in. We get A is equal to, why did this keeps disappearing? Oh, 4646.4. That's kind of cool. 4646.4. Neat number. So that means, let's be clear, so we understand what just happened. If my motorcycle started off being worth $6,000, in 2 years, it'll be worth $4,646.04. All right? It decreases in value because as things get used more, they lose value. Okay? Now let's look at one last problem. The population of cats in the Bronx, New York, can be modeled by the equation A equals 6191 1.04 to the t, where t is the number of years since 1994. What percent did the population increase by each year? Now, I know this sounds crazy, right? You have a population of cats in New York or in the Bronx, and it's going up every year. All right? Now, you want to figure out by what percent did the population increase each year, and I'll show you how to do this, okay? Well, to figure it out, you need to find out the R, right? We're trying to figure out what R is, all right? What is R? And you might remember this is the equation. So it's A equals A0, 1 plus R to the t. To figure out R, I don't care about this number, right? Who cares about A? That's the starting value. So we don't even look at that. What you just do is you want to look at, man, I don't know why it does that. You just want to look at what's in the parentheses, right? Because that's 1 plus R. Since it's 1 plus R, to figure out what R is by itself, just R, we need to subtract 1 to find out the rate, the actual percent increase. So this is what you do. I'll show you how you do it. Since it's 1 plus r, you're just going to have to take that 1 away. So you take this value 1.04, and you're going to do 1.04 minus 1. That gives you 0.04. Now this is not the percent. To get a percent, you always multiply this number by 100. Alright, and that gives you 4. So this increase is 4% each year. So the cat population goes up by 4% each year. Alright? Now let's be clear here. All you do is you look at the number in the parenthesis, you subtract 1, and you multiply by 100. I'm going to say that one more time. All you do is you take the number in the parenthesis, you subtract 1, and you multiply by 100. And that's how you figure out the percent increase or decrease. If this number is less than 1, then it's decrease. If it's greater than 1, it's increase. Look at the questions. Now, on the next page are the questions for you to do. You're going to do all the questions on the next page, and when you're done, you come show me, and I'll give you your independent practice for the day. And that shows me you got it. Okay? That's it for this lesson. That's it. Yeah. Wait. So my computer's kind of freezing.